Good morning, everybody. There are 2 more minutes of Codeforces round. I didn't participate, but I've read the problems. So what looks like ABCDE is enough to win, and well, necessary to win. What is interesting is that 2 people have ABCDE, but the second one is on the 3rd place. Well, C is only worth 1,250. Hi, Volsmile. I'm fine. So, welcome everybody to the stream. The plan for today is to do some Codeforces. Привет, hello. To do some Codeforces. I will in particular talk about problems here in this current round from also yesterday. Not from yesterday. Yesterday during a stream I implemented some problems from tourists round, and for E I think I understood the solution, but it looked very tedious. I will try it now. Maybe I will try to come up with something better. By better I mean, easier to implement. Also for now, while I'm not coding, I can make my face bigger. And it's done. So I can talk about problems. I wanted to participate actually, and I started solving A. Also, I kind of didn't want to participate. For example, I wouldn't have time today to eat lunch. But I spent so much time on A, and other problems, just after glancing at them, they didn't look interesting. So I decided that I'd rather have lunch and just calmly think about problems. So in a moment I will talk about my thoughts that aren't confirmed by any submissions, so maybe I have something wrong. For problem B, I thought about it only for 10 seconds, so I will now, like kind of live, try to solve it. I think I can solve ACD. And what was E? And I had some ideas for E, but also this one looked cool, so I will try to solve it during the stream. So ACD, I will talk what I think is my solution, though I see a lot of people in the top not solving it, which is suspicious. Maybe my idea is wrong too. Also, everything here is fine. Yeah, it looks okay. I have a chat. Hello everybody. So for problem A, if the input is just height and width of something, you can implement a brute force, and I even have one. Where is it? Genie ACPP. There is something looking like Fibonacci numbers here. Well, I can use my actual solution instead of a brute force, where I printed a table I have a recursive solution that works in complexity 2 to the size of grid, that just tries every possibility for every cell of the grid. And here let's print with exactly 3 characters this formula of mine, but previously it was that recursive thing. Then new line. No, I meant INJ. So I think the easiest way to solve this problem is to just print this table and notice some relations. And after seeing a number like 56, my thought was, oh, maybe those are binomial coefficients, but 30 and 40 are not. And then I noticed that the differences in every next row are the same. This number is bigger than the previous one by 6, this one is bigger than the previous one by 6, and so on. What means that just I'm interested in the first row and in the first column of those, well, which are both the same. And those two together, they should give me the answer, which is like, what is it? It's 42 plus 10 minus 2 is this number. And then from this, it's enough to just compute one row. And for one row, there is an easy relation. Every next number is the sum of previous two. But actually, what we see here, so the answer for 1 times something in this problem is just Fibonacci number doubled, because of what the DP relation looks like. We cannot have like 3 same things in a row, then dp of I will be the sum of dp of I minus 1 and minus 2. Thanks a lot for the timing of the stream. Yeah, I think it's good to talk just after the contest, but because of that, I'm not sure about my answers. So like, we need to wait for system tests, for systests. I guess they will not post editorial for quite some time. So there will be some discussion here. I will take a look. Yeah, the order of difficulty looked bad. People didn't solve B. Diff1C is the most frustrating problem ever made. What is pretest for? Yeah. I strongly dislike that the sample in problem C doesn't show that there can be a queue. It's very easy to misunderstand the problem. I only realized with 2 minutes left that Q stuff from C statements was actually relevant. Okay, so let's try to solve C. I will describe my solution. In problem C, and now I will need drawing C, Q in the train. I think that the described process is hello, ready. I think that described process is there are n people in the row, and for each of them we know when this person will want to go to get a water, like 0, 0, 30, 70, 35, 7, and so on. And the water is here on the left. And so this is a moment when a person becomes available. So let's say that before that, the status of every person is off, that he doesn't want to do anything. Then this changes to waiting and waiting at the same time, because it's 0 and 0. Then the leftmost of them is changed into Q, because it goes to Q in the water and it will take him some time to do that. And so generally at every moment of time, some people will be in the queue, maybe more than one. Let's say that it's here, here, and there. Now, if some person, this time when some person wants to go to get a drink, becomes available now, it's this time. So let's say this person becomes from off changes, it was off, and now changes it into waiting. And it's on the left from everybody in the queue, then it's changed into a queue. So basically I would need, I think, a set of those positions, or maybe pair, no, just set of positions will be fine, or set of indices. So this will be things in queue. And then generally we have one big priority queue of events. So at the very beginning, each of those things from the input I put as event, that this person is changed from off to wait. When somebody becomes waiting, then what happens? He waits for a moment. Every time if there are several waiting people, let's say waiting here, waiting here, waiting here, then it was said that only the leftmost of them can go to the queue. So after each of them, I also have set of int waiting. Also, those will be indices. And after every event happens, I take the first of them and compare it with the first of this set in queue to see if this W is on the left from this leftmost queue. If yes, then I add him to the queue. And then when somebody goes to a queue, I know when he will get out of there and sit again. So then the differences of status is from off to then waiting, then queue, then let's say dead, which means will not do anything anymore. And this first stage transition is exactly in the moment given in the input, and he's added to the set waiting. This thing is checked when every event happens. When somebody becomes dead or waiting, we compare the first element in set wait with set queue, and then if somebody goes to queue, we know when he will get his water. It was given after some time p given in the input. He becomes dead, so he's removed from a queue. Maybe because of that first element from waiting will be before first element in the queue. That all looks doable in a few minutes, but it's terrible, really terrible, that the sample from the statement wasn't clear about it. I analyzed this sample as well on a piece of paper, and it would work even if there was no queue. Every time just one person was in a queue. Did you participate in this diff1? No, I didn't. I wanted to, but also I was short on time. So after struggling a moment with A and glancing at other problems and also at the leaderboard to see that it doesn't look interesting, I decided not to participate. But for example, E looks cool. I thought a moment about E. The situation was when I finished A already, some people solved it, nobody solved anything else. Also there was 6 problems. So it would be hard for me to go through all of them if I spent already 20 minutes on the first one. So I just wanted to read problems, think about them, and eat lunch. Okay, that was problem C, at least a solution in my opinion. I can refresh here. I don't want to read the solution for B because I want to try myself. Try to solve the problem for 1 times M table, then you can see that in only 2 cases second row isn't unique. Okay, so there is a solution without noticing a pattern in the output with brute force. You forgot to sort problems. Yeah, the difficulty balance wasn't good. I understand that diff1a is about observation, that there is a repeating Fibonacci pattern, but how did people find those patterns in 3 minutes? Well, you can... Oh, common standings. Oh, I can see that. So indeed, this person understood. One thing is that you can know a problem like that. The second is that it's obvious what happens for just 1 row, and then even by looking maybe on this sample test we can see when we can continue this down. But I wouldn't be able to solve this problem in 3 minutes, so I cannot answer this question. Is this problem quite short in terms of statement? No, it isn't. So I wouldn't say that it's a known problem. while sometimes I am close to getting first accepted in the contest, or maybe even I have the first accepted submission in the contest, here I have no idea how to do it that fast. Here also this person understood that it's about Fibonacci. Though, didn't we have overflow here? Oh, he used long longs. Because if you use the sum of three numbers and those would be ints, then this would overflow. Okay, see. I think I also can solve D. In this problem, what happened? We were given a bipartite graph. Katowice is, by the way, a city in Poland. We were given a bipartite graph. Each side had n vertices. There were some edges, including edges that connect ith vertex on the left and ith on the right, plus some extra other edges. Like that. And now the goal is to choose such a set of exactly n things. So n vertices should be chosen in the set. At least one on each side. And there should be no edges between them. So this, for example, is a bad set because is it? No, it should be good. Yeah, so this is an example of a good set, but this one is bad because there is this edge. And because there are there should be exactly n vertices, and we have those horizontal edges. By the way, if you have some strange condition like this one, that all horizontal edges are there, for sure you should use it, because why else there would be such a condition in the input. And the thing is, for sure the solution will look like this. You choose something from the left and everything else on the right. And this means that if you look at those things chosen on the left, they can be only connected to their counterparts on the right. It's similar to Hall's theorem. This time we are looking for just one set that satisfies something. Hall's theorem is about subsets of vertices on one side such that their counterpart on the other side is at least of this size, at most of that size. Here it's a bit similar. We are looking for such a set on the left that contains at least one element, that and not all elements, at least one, at most n-1, that their vertices connected to them on the other side are exactly those, like the matching ones, and then the solution would be to take everything else. So the how is it called? Everything but that. This would be a solution. So brute force way would be to try to start from some vertex and then just to do some DFS. If we know, maybe we can look at on the left. If we want this vertex to be in the solution, then he's connected with this one and this one, so those cannot be, and then this one must be. So it's kind of DFS that goes like that, and here we have a valid solution as well. So those three can be taken. If we take something from the left, we cannot take anything from the right that is connected to it, so we cross this out. And if we don't take this one, then for sure we take the one on the left. So the quadratic solution would be try from each of them and do this DFS, basically an edge like this means if you take this vertex 2, then also you need to take vertex 4 from the left. So basically we're given a directed graph. On vertices on the left, there's some directed graph. And we want to start somewhere so that we will get not to all vertices. And that doesn't sound hard. We can find strongly connected components. Then what remains is a DAG, directed acyclic graph. If everything is just one strongly connected component, there is no solution, otherwise there is one. Like in a DAG, if we have something like this, then just take this last vertex. In a DAG, just take some vertex that doesn't have anything going out of it. In particular, there is topological order, so to then choose the last element there. I would say that this is the solution. Maybe I can understand from somebody's code. We have strongly connected components. If current does this count? I guess if this is 1, then no, otherwise there is 1. I would say that it's a nice problem with some observation in the process, but the solution is standard, not hard. In C, it was hard to understand the statement. In D, everything is fine. Now I don't know solutions for B and E. I will think about that, and F looked hard. Oh, actually, I didn't even read F, but it looked like some graph, and I'm not good in graphs. Maybe B first. What's up in the chat? Div2C is same as div1A. That's true. I will also sometimes refresh the main page. I mean comments to see what is happening. So people complain, I guess, about problem C. So the sample was terrible, and other than that, the problem was fine. This should be as easy as C. The problem is there is bracket sequence in the input. We can rotate it or not. We can swap two characters and then what? I don't remember. The beauty of the bracket string is a number of its cyclical shifts which form a correct bracket sequence. I will take a look at the... Oh, by the way, I can decrease my face now. And the samples are here, swap sum to... I don't think samples will help me more than just some random test. How long will the stream last approximately? I planned for 2.5 hours, I guess, so 2 more hours, not more than that. I will see how the problems go. Now I will think about B. I will try to solve it, then E, and then E from tourists contest. What would your n-cubic solution for diff1b be? Just try every possible swap, then try every possible shift. We'll go through that. If you have, let's say, without swaps, what happens? I need something that has the same number of opening and closing brackets, right? Otherwise the answer is 0. So 0. There are here 4 closing and 2 opening, and here there should be matching. Okay, there should be at least 1 matching. Otherwise, if the number of opening and closing brackets are different, then just print 0 and swap whatever. What otherwise? So let's start with something that is a bracket sequence. Free opening. This is valid. And now, what happens if I rotate it? Isn't it just that if I have some substrings that are completely correct themselves, then the number of possible shifts is just like to how many parts I can split that? I cannot split here. In other words, this such, like if I treat each of those as +1 and -1, then I can make a graph that looks like this. And the only possibility to shift it so that it would still be valid, like nowhere we go below 0, is just this. What means the problem is maximize the number of points that are exactly on this level of minimum. Does the string need to be balanced itself? Not necessarily distinct. We can swap a character with itself. Okay. Then if I have some drawing, let's say this one, and here I want to swap this +1 with this -1. What will happen? Maybe -1 with in red. Here I will get -1. The whole drawing will shift by 2 because of that. And then here I get +1 instead of -1. So the whole substring will go down by 2. And after that, the score is the number of points that are at exactly the minimum. Well, this point is the same as that one. So after this shift, I find the minimum, and the number of points there is the score. So what? So what? We have some minima already. Okay, basically this, I can say that those numbers are in a circle, or those brackets, then I split them into two, and for one part I say everything is changed by -2. After that I want to have as many minima as possible. For example, if there are numbers 3, 3, 3, 3 here, and everything else is bigger, like 4 and bigger, and here if there are 5, 6, 5, 6, 7, then after those 5s also will become minimum. Then I would say the solution is find minimum in the sequence, and then find between every two consecutive minima, like between this one and this one in this part. No, this part shouldn't have any 4s. It should have only 5 and up. Find some long part that has a lot of 5s and nothing smaller than that. Does that work? Okay, let's say this is the circle. 3 is a minimum. And then I would want to find this part that has a 5 and another 5. If I say -2 here, those will become minima as well. So the answer will be the number of those before and these two. So between every two consecutive 4s on the circle, just count the number of 5s. If the minimum is m, then between every consecutive m+1 and somewhere else m+1, in this interval between, count the number of m+2. And if this can increase the answer, the maximum out of those possibilities should be added to the answer. That's my guess. This works. Why? Because overall bracket sequence can be transferred to correct bracket sequence with some shift. Well, I started solving this problem by analyzing that the score of a string will be the number of minimum, in my opinion, of that graph. I can analyze the samples for first and second one to see if it works there. Not that it means the problem will be solved. Here I have what do I have? Up, down, up, down, up, down, down, up, up, down. This was the drawing representation, but actually I'm interested in numbers that are 0 for empty, then 1, 0, 1, 0, 1, 0, -1, that was -1, 0, 1, 0. That's first test, and then -1, well, first 0 for empty, 1, 0, 1, 0, 1, 2, 1, 2, 1, 0, 1, 0. Okay, this is minimum. And I want to decrease everything else by -2. That will not work. Oh, because here a possibility is to just decrease everything else by -2. And then all of those, and this is repeated, will become new minimum. What I considered before here is how to maintain the same minimum, but also maybe there will be new minimum. Okay. So just between every two next occurrences of minimum, count the number of minimum plus 1 and consider that as an answer. This is one thing, and the other, in the second problem, again we can do the same thing. 1, 2, 3, 4, 5. Oh, we can get 6. That's cool. One possibility was to say that those will be minima. But instead, what should I do instead? I would say that we decrease by 2 this part, but this will only increase the answer by 3. So those will be minima. There are 4 of them. They say, oh, I looked at the wrong problem. Second test. The output is 4. So can't I get answer 5? To say that those are minima? Oh, it's also 4. The samples are terrible again, I would say. Because they don't check anything, or maybe I'm wrong. In my opinion, we should find where minima are, then between every next two occurrences of this minimum, count the number of second minimum, so this minimum plus 1, and do some ifs with that. I believe it's tricky, especially with bad tests. There is an announcement in problem B. Thanks. But I didn't read the explanation. I'm not worried about that. Plus, likely they also corrected the statement already. This graphical representation of the question is very cool. Thanks for sharing. Yes, for brackets, you should always think about this graph with going +1, -1. Things like check if substring is a correct valid bracket sequence can be very easily checked if you think about a graph. What's up here? And I will now try to do something with problem E. Turtle. Where the statement is that standard problem mean path in a grid. Where given a grid, you need to go from top left to bottom right corner, but you can rearrange elements first. And if this turtle wants to maximize the total energy value, so it will be maximum possible path from top left to bottom right, each time going only right or down. But you can rearrange elements first so that he would have very bad answer. That's the idea. there he maximizes. Likely if the input is something like 3, 5, 1, 2, 7, 4, then the turtle can choose this path. He wants to go from top left corner to bottom right. But you can rearrange elements. Maybe I can leave that. You can rearrange elements. For sure I will make top left corner and bottom right to be bad. Maybe 1 and 2. And then 5 and 7 are very big. So I will make it in such a way that he cannot take both. Then after, I think here it doesn't matter anyway because he will choose 7. So this is now optimal. So from the answer 19 we got down to 14. And the height of the grid is 2. The width is actually n in the statement is up to 25. Such a small constraint means, for example, meet in the middle or bit masks if they are fast. But also the values were suspiciously small. Aij is up to 50,000. So maybe this will be in the complexity. So how can this be in complex? I don't know how to solve a problem. I'm just experimenting. How can this be complexity? We have this grid. After you already chose some, let's say you chose numbers here, then there could be some DP that goes from left to right, and it would compute some value if you need to cross this edge and when you need to cross this edge. Let's say maybe to get here you can have some 70, and to get here you can get some 85. Okay. And then I would say that for sure I already have 70. I want to minimize that, and I can get extra plus 15 if I decide to go down already. But the disadvantage of that is that then I need to go just right all the time. Well, if I'm here above, then I have a choice. For some time I can go up. So maybe like the value of this is just limited by a of ij. Because in particular, after getting here to this 70, we can just go down and to the right, or not. No, that isn't not true. If I have a grid like 1, 1, 1, 1, and here infinity, 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 then dp at this point is 4, and dp at this point is 4 times infinity. That was a bad idea. That's something. Or we do divide and conquer. So split with very middle line and do something from left and right part. But the number of things in the input is 50. So it's 2 times 25. And here, even on the left, we have 25 values. And if I want complexity like 2 to 25, it will be a lot of time. Is time limit big? Yes, it is big. So maybe. But why length wouldn't be like 22 in that case? So fast 2 to 25 should be okay. Oh, but I would need... I think, complexity 50 choose 25 to say what should be on the left and what should be on the right. maybe some greedy works. Just put smallest here, then big value there, and odd second bigger value there, and continue doing so. Like here, first biggest, fourth biggest. So maybe the order of values should be 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11. Am I right here? No. 10, 11, 12, 13, something like that to no, not to give him a lot of big numbers. Can I become a programmer if I am blah blah blah? Yes, you can. Especially if you graduated maths. I want to copy the template. If I chose those already, maybe I can assume that after saying that this is small, this is like 1 and the last one is 2, maybe I can say that those will be 3 and 4 in some order, then 5 and 6 in some order, and so on. This is very random guess. And then it will be like dp of a difference, I guess. The dp of getting to this cell and to that cell, I claim that they will not differ too much. I want to say dp of this. I will go diagonal by diagonal. Diagonal. And the second thing is difference. And maybe this is up to around 10 to 5. From minus 10 to 5 to 10 to 5, and this is 25. And then I just consider putting them in order, 7th smallest number here, 8th here, or the other way around. But that would be very fast, and while time limit is big, so that shouldn't be the intended solution. Like, can you share any idea to solve this problem? I'm solving a problem now. I will not stop to solve another problem. Okay, so O of this value times 25 seems too small, because that would be a few millions, while memory and time are huge. Maybe though, maybe this diff is up to n times value, then the total complexity is O of n squared times value. For sure this is limited by n times value. And that makes sense. Also, the memory is big. But I assume that it's okay to put them in this order, like 3 and 4 or the other way around, then 2 next bigger numbers here, and so on. This is very, very risky. So let's try something completely different. Mm. To fight with this turtle, it's good to make a lot of paths to have similar sums. I would say that it would be perfect to put the same number here and there, because you have a choice. Like if you get to this cell and then you continue from that cell, then those two should be very similar. So I will claim that those two are indeed two consecutive numbers, but then does it matter if they are in this order? Can I say that those are 3 and 4, like so if counting from smallest? Or maybe here I should put 5 and 6, and then here 3 and 4. So then I will say that we have 24 pairs. I'm putting smallest number in top left, second smallest in bottom right, and then we have pairs that I put as next, diagonals. Can I do them in this order? Well, samples again didn't check a lot. This would give me of 2 to 24 times stuff, but this stuff I cannot do fast without this DP. So at this point during a contest I would implement this solution with DP, where I assume that third and fourth smallest numbers will be put there, and I will continue so with every next diagonal. So to sum up, smallest number, second smallest number, then next two will be here as blue, then next two will be here, yellow, then next two here, green, and so on. And I'm out of colors. I can also use gray. Perfect. Looks plausible. For functions, I don't have 2 to n in complexity, so it's not my solution. This might be my solution. We have here 1 million, which is smaller. Maybe this is also enough. This is deep. Oh, n plus n. Then it's fine. This is my DP. Sort the input. Take all numbers except for the first two. Have that, the DP of 0, 0 is 0. I is an n. What is an n? The sum, like it's 50. J is sum. So DP stores the previous best cell. What is I? I is index. DP will only store things from 1 to 25. I have no idea what I'm looking at. J is up to some. X of I. Do we use X of something here? Yes, we do. So we assign every next number in some way. Numbers up to I. DP of ij will be some index if we think about numbers are up to ith number. It's hard for me to understand just from this code, but it wasn't my solution. I will just wait from the editorial. I'm assuming that something like that. My random guess wasn't correct. Yeah, here we have 2 to n. Maybe there are multiple possible solutions. So that's it. I guess I would solve ABCD in finite time, but it looks hard. And here it wasn't optimal to solve both B and C, because they weren't worth a lot of points. So that's it about round 594. Now I will get back to problem from tourists round. It was final standings. I can or submit my A at least. Problems. Hop. Does it work? 2, 3. Yes. Submit. Looks okay. Okay, where is this round? Accepted. Yay. There was problem E, balanced binary search trees, where I figured that FFT, this can be done with FFT, but in some very ugly way. Because of the parity condition. We need to count trees such that parity of root is the same as parity of thing on the right. Maybe it won't be that hard. If let's say we want vertices from 1 to 10, then it was okay to say 10 is here. The parity with the right side is the same. No, not 10 here. Let's say 6 here. Then here we need a subtree with 4 vertices, because this is a binary search tree. Everything on the right is bigger. from 7 to 10. This root needs to be even. And what here, something odd. Vertices 1 through 5. It's okay to combine size 5 from the left and 4 from the right. But what happens if I consider 5? Then I have here 4 on the 4 on the left, 5 on the right. Your size is 5. And now this needs to be odd, the same parity as the root. And this is even. So in both cases, we needed a subtree. Both this one and this one is a subtree, so that will be dp of 4 even root. And first vertex is odd among those that should be put there. I think that's important too. So first odd. And for the other type, we have 5 vertices, but here the first of them will be odd, here even, and the root needs to be odd as well. That still looks very, very ugly. We have this convolution over something like dp of I times dp of j times dp of j. This contributes to dp of I plus j. And without those extra dimensions, that would be standard FFT, and now it's very ugly. Can I get rid of those? I don't think I can. Maybe the editorial will tell me how to make this nicer to implement. Let's see. 2 tutorials. It's the same. I don't want to read everything. Consider perfectly balanced striped BST of some maximum depth. Both children must be perfectly balanced of depth smaller by 1. Note that the parity of the root must be equal to the parity of n, as n lies on the rightmost branch of the tree. What? Parity of the root must be equal to the parity of n. Thus the size of the n lies on the rightmost branch of the tree. I agree with that. Wait, so they claim that for depth 10 the root cannot be 5? Oh, because everything here also will have this parity. Okay. Okay. So this must be 6. And then what happens here? We have vertices from 7 to 10, and parity of this one must be the same as that. Okay, that gets rid of the condition completely, because if here vertices are from 1 to 5, then automatically the parity of this one will match, because it's the same as that. So, okay, I like the problem. It's very, very cool. This is enough for me. I don't need to look further. Basically, this case wasn't possible, because then this thing is odd, the right child, and its right child, and so on, and eventually the last leaf, rightmost leaf, that should be equal to 10 needs to be odd. Here we go. So we just have that. For example, for 10, this is 7. 1, 2, 3. I think for 10 before I thought that the split can be how many go to the left part. 1, 2, 3, 4. I thought that it can be 6, 3, 5, 4, 4, 5, 3, 6, but those two are impossible. The left size plus 1 must be the root. 6 here is okay. Then for 11, what then? The left part is 7, okay? 7, 4. Wait. This is 1, 2, 3, 4, 5, 6, 7. Hmm. 7, 3, 6, 4, 5, 5, 4, 6, 3, 7. And then parity of n and the size of left one cannot be the same. For 12, it will be 7, 4, 6, 5. I'm writing down possible size of left tree and right tree. 5, 6, 4, 7. Parity cannot be the same. And so on. I think for 15 it needs to be 7, 7. But the parity cannot be the same, so this is impossible at all. For 16 we have 8, 7 or 7, 8, and this is impossible. I guess I can start implementing this. I will write brute force first, then I will make it to work, and I will try to replace that with FFT. Okay, that's a nice problem. How do you write that code in Notepad? Do you use your mouse or some kind? You know, you can read frequently asked questions. I have a drawing tablet. But when I don't stream, I just write on a piece of paper. Go to tourist directory and here copy templates to ECPP. Open ECPP. Have some modulo 998.244.353. Let's read n, create dp of size n+1, at the end print everything in that dp. Let's say that dp of 0 is 0. Maybe let's call that uppercase n. For every n up to this uppercase n, the parity of the root must be something. If n is, for example, 7, then I need to split 3 and 3. N is 8, then 4 and 3, 3 and 4, and so on. Then n is 15, again 7 and 7. Well, 0 is also possible. N is 3, it will be 1 and 1. So dp of 1 is 1, dp of 2 is, you can say 2 is here, 1 is there, it's also 1, I hope. And then dp of 3 will combine. Why this is wrong? Oh, because what the root will be. Okay, so for 7, this left part is at least 3, at most 3. For 15, both are at least 7. What happens for n? 14, we have 6 and 7, or 7 and 6 sizes of parts, so that everything there would be balanced. What means that this is 1 and 2, 2 and 1, 1 and 3 is possible? No, yes, it is. This is kind of a series. This is another series. Okay. From 4 to 7, we have 1 and 3. I will say low is 1, high is 3. Root is 1, root small equal n plus plus root. if L is root minus 1, R right is n minus root. If root modulo 2 is n modulo 2 and low smaller equal min of LR and max LR smaller equal high, then dp of n plus equal dp of L times dp of R. And for now, okay, I can use module, whatever. Okay, and then when I reach this, if n is 2 times high plus 1, low is high, high is 2 times high plus 1. So from interval 3, 7, I now have 7, 15. Or from 1, 3, I have 3, 7. Those shouldn't be that small. Maybe they should. I don't know. But there are a lot of zeros here. Let me cheat a bit. I will open somebody's code. See tests. Is this E? Oh, this is, yeah, this is E. Why the input is so big? Okay, wrong code. So the answer is very small. It is 0 or 1. Is there a pattern? Up to n. Four, 5, 9, 10, 20, 21. I think there is some pattern here. What? 84. So it's like the answer is usually 0 and just sometimes it's 1. 20, 21. Interesting. Let's say that if dp of I, just print I, (1000), and do we see a pattern here? Here it's times 2, here it's times 2 minus 1. Times 2, times 2 minus 1, times 2, times 2 minus 1. Why don't you try Codeforces contests? I try Codeforces contests. I did some of them, but the average quality is worse in other platforms, and I can tell you the exact reason. They have regular scheduled rounds instead of that, they should hold a round when they have interesting problems. It's a very bad decision to always have a contest every month at some particular time. They don't have enough quality problems. I was an admin, problem coordinator in CodeChef for half a year, and it was very hard because there weren't enough ideas for good problems. Because of that, either the contest should be postponed or something stupid should be used, but they have a fixed schedule. What's going on? I'm solving problem E from Gennady's round. Okay, 1, 2. So for those, the answer is 1. Then smaller equal than, I don't know, whatever. A times equal 2. Yes, push back A. Yes, push back plus A. You have that, then times 2. Let's push back A. Let's push back plus A. X is n. Say 1 and return 0. Otherwise, say 0. One, 2, 3. That was called, I think, tourist ECPP. I completely didn't expect that to happen. So you wouldn't recommend Codeforces? Yes. In my FAQ, you will have a question like which platform is good. Topcoder is cool, Codeforces is cool. Wrong answer. So my output was 0, jury's answer is 1. Maybe my solution isn't correct. Oh, this thing doesn't print what I want it to print. Let's print things in yes. Okay, it's not. It should be -1. I should have checked that before. Yeah, now it's okay. And so without that and submit. Problem E, balanced binary search trees, and that. But I wanted to use FFT here. Everything looked fine. How do you compile CPP code on Windows? Looks like a question that you should write in Google. I emulate Linux in my system, but it is also possible to compile CPP code in Windows. You need to install CPP environment. I think code blocks is the easiest. Okay, running on test 29, so looks correct, and it's time to read the editorial. Consider trees of maximum depth 2. There is one with that and one with that. Okay. Oh. I liked everything about this problem till I noticed the pattern and that answers are just 0 and 1. Otherwise it would be very nice hard problem. Now I don't really like it. Accept it. Did people submit FFT? I think I saw their brute force. Yeah. Just to figure out a pattern. 25 minutes likely means it's not FFT, it isn't FFT. Not FFT either, but not necessary, just hard coding the pattern. Something short. Something short. I will go to submissions for this problem. Status. Problem. Any problem. Problem E. Accepted. Whatever. Apply. And now, 2 seconds. FFT. Yep. So it is possible. This sorts, I guess, by time, by judging time. Yep, FFT as well. It's perfectly cool that there are multiple possible solutions, but just there were so many things that suggested it's FFT, including the fact that normally it will be log square, but because of what we combine here, it's only n log n in total, amortized complexity, 400 milliseconds. Is this FFT? No, it isn't. Okay, cool. I think it is possible to modify this problem just a little bit to make it slightly harder, and the intended solution will be FFT, and everybody will be happy. Well, everybody would complain that it's FFT. But yeah, I solved AF and GH are quite hard. Would you screencast upcoming lead code contests? When I have time, yes. Okay, now 2 next things for me to do are, what time is it? It's hour 30 already. Okay, 2 next things for me is write editorial for my Topcoder round that was a week ago or 2 weeks ago for div2 problems, and then I will go for a moment for my GitHub, not how to practice. I have a lot of things here like current nodes, current to do, work on chatbot. Maybe I will do some chatbot here. Yep, I will do that, but first, Topcoder editorial. I need to find it. I will be back in screen in a moment. Just need to find it in my Google Documents. SRM 767 editorial. No, it's not my SRM. Maybe owned by me. .768. Here we go. Also problem archive. Okay, I'm back. What is already out there on Topcoder website is tutorials for Division 1 problems, median, PUBG. Oh, by the way, I'm very sad that nobody appreciated problem PUBG about a game with tournament and eliminating opponents and places like that. It was completely inspired by the game PlayerUnknown's Battlegrounds. I think it isn't that popular. And I use the fact that PUBG stands for Polar Brown and Grizzly Bears. In Division 2, we have alpha. Limac tries to say the whole alphabet from A to Z. Your job is to stop him when he makes a mistake. Can you check how many first letters he said correctly? So A, B, C, T, and here T is wrong. Then return 3. Okay. This is Division 2 alphabet. What is the name? Alpha. This was the easiest problem, so nothing much to say here. Given a string with lowercase English characters or letters, how do you say it? A lowercase English characters. Nope. Find how long prefix is also find how long prefix matches the English alphabet. For example, given ABCT, the first paragraph of tutorial here should be just summary of the statement. For example, ABCTYF, return 3 because ABC is also prefix of English alphabet, but then T doesn't match. Do you play video games? Yes. Read FAQ. Can you please make video on problem setting? I already did one, but I will do more in the future. I recorded, I think it's on the Errichto 2 channel. I recorded the process of preparing one of Codeforces problems. It was walkways. ABC is also a prefix of English alphabet, but then T doesn't match. Okay. We need to compare the ith character of the given string with the maybe one naive option is to copy the whole alphabet from the statement, save it as a string, and use a function say use a function to get a substring of a string. To get a substring from 0 to some position I of a string. One naive option is to copy the whole alphabet from the statement, save it as a string, and use a function to get a substring, a string in order to compare to prefixes. Do I have here add-ons? I do have one. So this would be something like for I is 0, I up to n, I plus plus, if given string what s as subst from 0 to I is different than s than alphabet subst 0 I, return I. This is pseudocode. Later I will paste actual code that was the intended solution. What I can do now is another blah blah blah. I can color this. Language, say C++. Well, actually it will be in Java. Team Monaco format. Nice, isn't it? We have here one line empty. Okay, this is fine. There is the approach above would be of n square, which is the approach above would be n square, which is very fast for small constraints, but there is a simpler and faster approach. It's enough to just compare the ith for every I, index I. We need to compare the ith character of the input with the ith English letter. If this if s of I is different than a plus I, return I. Of course, otherwise we need to return something else. This is linear. This solution is obviously fun. I should also maybe comment about this thing, that you can get the ith character of English alphabet by adding to character A, just I, you know, like A plus 1 will give you B, A plus 2 will give you C. To compare the ith character of the input with the ith English character, getting most languages the latter is easy because we can add something to a character. Add a char with an integer to shift it. For example, A plus 2 will give you C. Yep. People often don't realize how important easy editorials are because everybody starts at some point. And I even heard an advice that each editorial to each problem should have similar length, because it's hard to do that for a very hard problem and very easy problem. Like, what else would I write here? But you want to go into detail with stuff like that. If somebody wants to read this editorial, then for him apparently the problem was too hard, or not easy at least, and then you want to talk about those details, which is very fast for small constraints, but there is a simpler or faster approach. For every index I, we need to compare the ith character of the input with the ith English letter. The latter, people will not understand that. The ith character with the ith letter of the alphabet. For every index I, we need to compare the ith character, the input with the ith letter of the alphabet. Is getting is easy because this should be m dash, how to say it here, alt control minus, no, no, this is too long. Grammar is hard. This is easy because we can add a char with an integer. For example, a plus 2 will give you C. The approach above would be n square, which is very fast for small constraints. Still, there okay, but there is simpler and faster approach. For every index I, Have you learned C++ STL? I don't know. When I needed a new function or I saw something in somebody's code, I googled that function. I struggle with iterators. Cover some course of C++. I have a problem, ask me in Samsung interview, ask on Codeforces or LeetCode. OneNote for doing this, it's very easy to organize. How is OneNote better than this? I use OneNote for, here I did. How is it better in any way than Google Documents? Because I think it's worse. Google Documents are very convenient and easy to share, and that they work in browser out of the box. Also, and OneNote is limited, right, or not, in the browser. Do you know any website on which I can connect with, reach out to like-minded competitive programmers? Codeforces. Discord server, yeah. There is link to Discord server in the description of this video, of this stream. Okay, we have this. Then second problem is binary distance. It wasn't very easy. In this problem, given a tree like this, we are given only n, the size of this tree. There is like a full binary tree. I don't know a name for that. Like a perfect binary tree with some last leaves removed. Not really balanced ones, because now for n5 I have something like this: 1, 2, 3. So every next leaf, this is a tree for n equal 4, then this is for n equal 5, and so on. Given some vertex, n is up to billion, and given some vertex, we need to find the furthest vertex from that one. In a big binary tree, to find a vertex that is furthest from V. Actually, farthest, right? The tree is very regular. Every next leaf, it's a perfect binary tree without some last leaves, without some rightmost leaves. A się trzaskasz? Rightmost leaves. This was alphabet. Formally, we just say that for every vertex x from 2 to n, there is an edge between x and x over 2. In a big binary tree, we need to find a vertex that is farthest from the given vertex v. The tree is very regular. It's a perfect binary tree without some last rightmost leaves. Formally, we just say that for every vertex x from 2 to n, there is an edge between x and x over 2. The problem, do I leave an empty line here? Yes, I do. One naive, not option, one naive solution. Save it as string and use a function to get the substring 0 to I of a string in order to compare two prefixes. The problem would be easier for a perfect binary tree. exactly to 2k vertices in the cave layer. The depth of a tree, depth of any vertex from any vertex, it's optimal to go up to the root and then down to the other branch, left or right. Then down to the other branch and down till a leaf. From any vertex, it's optimal to go to the root, then down to the other branch, left or right, and to some leaf eventually. Problem would be there, blah blah blah. The farthest vertex must be a leaf. The leaf and it makes sense to go up for the furthest vertex must be a leaf, so the longest path from V must be go up for some time, keep going up for some time, then down to the other branch, left or right. Do I want a formal proof of everything here? The thing is, in such a tree, if you start, let's say here, and you go up, it isn't optimal to now start going down. Instead, you should keep going up. And then here. That. For any tree, the vertex from not only binary one, the farthest vertex from vertex V, fixed vertex V, must be a leaf. If the tree was given, no. Move. Okay. For any tree, not only binary one, the farthest vertex, even if the tree wasn't binary, still the just any tree, n minus 1 edges, just any tree. The farthest vertex from a fixed vertex V must be a leaf. The easiest algorithm to find it is DFS or BFS. We cannot apply it here because the tree is too big and we can't even explicitly store it. Let's analyze how to speed this up. I want to say something like, in order to find a faster solution, I want to move this thing. This is not what I wanted to do, but whatever. It's optimal, blah, blah, blah. Just any tree. The farthest vertex from a fixed vertex V must be a leaf. The easiest algorithm to find it. If the tree wasn't binary, just any tree, we could use DFS or BFS to find distances from V to all other vertices. We can't do that here because that tree is too big and of n is too slow. For any tree, the farthest vertex from a fixed vertex V must be a leaf. If the tree is binary tree, every path starting from vertex V looks like this. Keep going up for some time, turn then down to the other branch. If you came from some a left child to a parent, then go to the right child. And keep going down. in a perfect binary tree, it wouldn't make sense when we start going down, the farthest we can go down there is the depth of a subtree. Since the given binary tree is so regular, it's optimal to first go up to the root. It's optimal to first go up to the root because our path keeps getting longer. Formally to say the depth of a subtree of vertex x is not bigger than the depth of the other child. If vertex x has two children, C1 and C2, then the depth of a subtree of the depth of C1, I need to specify that depth of a vertex is maybe its height of this vertex. Did I use that before? If the tree blah 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 depth. Down there is longest number of steps down we can make is equal to the depth of a subtree. Since the given binary is so regular, it's always optimal to first go up to the root instead of stopping earlier in order to go down, because our path keeps getting longer. Formally, we need to say if vertex x has two children, C1 and C2, then the depth of C1, depth of a subtree of C1 is not bigger than depth of a subtree of C2 than 1 plus this. Is that enough to say then? Instead of going down from C1, it's not worse, it is better. I will say here 2. The depth of a subtree of C1 is smaller than 2 plus the depth of a subtree of 2. Then instead of going down from C1, it is better to go up to X and then down to C2. All that meant, let's repeat the important observation. From V, it's optimal to go up to the root, then down to the other branch. If we entered the root from the right child, go left, otherwise right. In case somebody is just now tuning in, I'm preparing an editorial for the past Topcoder round, SRM 768. This is problem binary distance. Then after that I will cover one more problem from that division 2, which is mean median count. From V, then down to the other branch. If we enter the root from the right child, then go left, otherwise right. We just need to compute the distance from V to the root, which is just the depth of V in a tree, and then the depth of the other of the subtree of the other child, the other branch of the root. The depth of some vertex can be computed easily by dividing its index by 2 till we get root. Computed by adding it repeatedly by 2. This is divide by 2. This will not work in some languages, but well, I think in Python we should say divide. We get the root. This is equivalent to iterating through a path. Step here means going to a parent, and we know its index is x over 2. Do not use logarithm. Theoretically, you can use logarithm function to figure out the depth of x, but do not do it if, but you shouldn't. It's a bad idea. Logarithm is computed with real values. Floating values, and there can be some precision error that will give you an answer different by 1. Theoretically, we can use logarithm function to figure out the depth of x, but it's a bad idea. Logarithm is computed with floating values, and there can be some precision error that will give you an answer different by 1. Produce. But it's a bad idea because the logarithm is computed with floating values. A precision error can use an answer different by 1. That's a long editorial, but it's meant for people for which this problem is hard. In short, use depths. In short, try to solve the problem for a perfect binary tree with 2 to k vertices in the kth layer, and then think when you should subtract 1 because some leaves are missing. Okay. We can already problem from a perfect binary tree. Answer is depth of v plus the depth of any leaf. In particular, vertex n is a leaf. The given tree isn't perfect though. Some rightmost leaves are missing. Yep. So it's something like this, and then from this vertex, when you go up, maybe with different color, when you go up, from here to the right, you will not find anything on that last layer. Thanks for making the editorial for Division 2. Well, it's my job because I prepared the problems. But sure, you're welcome. The given tree isn't perfect though. Some rightmost leaves are missing. We can if n, vertex n is in a left branch, that I need to define branch. Okay, I don't need to. The vertex n is in the left branch, the subtree of vertex 2. Then there are no leaves in the right branch, the subtree of vertex 3. And going down there, one solution is to increase n to be of form 2 to k minus 1, compute the answer for solution is to increase n to be solution is that we increase n to be of form to the next value of form that, compute the answer one solution is that we increase n to the next value of form. That gives us a perfect binary tree. Can compute the answer, then think whether the answer is decreased, should be decreased by 1 because of missing rightmost leaves. Think about. Okay, of missing rightmost leaves. If original n is in a left branch and if v is in a left branch, which means going using the deepest leaf in the right branch, and also n original text n is in a left branch, leaves in the right branch are one less level deep, so we decrease the answer by 1. The other solution is to directly compute the depth of a deepest leaf in a branch in the other branch, not the one in which vertex v is. Both solutions are off. And here I will copy paste the code. I have some, well, I created the problem for the contest, so I have some intended solution in Java. This created a long solution, but if you want to be formal, this is a long solution. Maybe I can make it shorter here and then say more details. Yeah, that's a good idea. Well, to go up from vertex V to the root, then down to the other branch. If we entered root from the left child, then go right, otherwise left. We need to compute the deepest deepest text in that other branch. It will be either vertex n, which is the deepest, the rightmost deepest leaf, or when it is not n. Nope. Rightmost deepest leaf, or the first leaf in that branch. That branch. For n is equal what was given in the statement 6. That would mean vertex 4. Example, for n equal to 7, the interesting leaves are 4 and 6. Everything else is redundant. I keep forgetting about T in rightmost and leftmost. More detail below. More details. And now I like the solution. So there is something short, and then there is long detailed explanation. I need code here, and then this is division 2 1000. Problem name is min median count. This is similar to the division 1 version. In that division 1 version we had some costs. Here just we need to count sequences that satisfy something. We need to count sequences of length n, where each number is from 0 to 10. The mean of those numbers is at least that, the median is at least this. And well, there is this version where I need to, a lot of things I will use the same. There are n subjects and your default grade in each of them is 0. I will just copy. Count the number of such sequences of n grades such that the mean of grades is at least that, and the median is at least that. But constraints are quite small. Modulo this. One alternative approach is dynamic programming, like in knapsack, since we have two requirements about the sum of grades and the number of grades not smaller than the need median. These two values should be dimensions of DP state. See this? Okay. Refer to division 1 median for needed observations. Small constraints and counting with small constraints and being asked to count sequences of some that satisfy something, you should for sure consider dynamic programming. You should definitely consider dynamic programming. One moment. Okay. After this last tutorial, I think I will finish the stream. I wanted to also go through GitHub wiki, but I don't have enough time today. I will do that next time. Consequences that you should definitely consider dynamic programming. It's hard to keep track of the median, so we need an equivalent condition. The median is at least x if and only if there are at least +1/2 numbers that are x or greater or bigger, higher. If there are because that would mean that after sorting the sequence, the last and +1/2 positions the rightmost are at least x, and thus also the middle element is x or higher. The order. Do we then need that? Refer to div1 median for some more explanation of the required observations. To avoid counting values, the mean constraint requirement be changed to the sum of all n numbers must be at least n times neat mean. Now we can choose sequence elements one by one and keep track of the number of elements that are x or higher. Needs median or higher. And the sum of elements. At the end, we know this can be done with dynamic programming. Complexity of n times n times n times 10. Times great. dp of prefix count big, and here sum in complexity of n times sum, which is of times n times 11, which is of n cubic. In the number of states is where g is 11, which can obviously be skipped in complexity if we treat it as a constant. From each state, you should consider each of 11 possible grades. And the time complexity is then n cubic times g square. Then I need to add some codes here from my laptop where I have codes, and I will ping the Topcoder admins to upload this to the website. Yep. I think that's it. I'm still a bit not satisfied with that problem E that I solved with answers 0 and 1, but that's fine. Next stream will be likely in a few days, like maybe Monday, Tuesday, Wednesday. Either next stream will be on Tuesday or Wednesday, or after the whole week, because on Thursday I'm going to Facebook Hacker Cup in Ireland to the on-site finals, so I will be out of town for a few days. But for sure, at least I will upload already ready videos that are Kickstart, Google Kickstart that was yesterday, plus randomized algorithms lecture. So, yep. See you in the next stream or video. Thanks for watching. Bye.